Hello, everyone. Sorry I cannot be there today. Getting ready for my wife's surgery coming up on Monday. But we're going to kind of jump into our last unit that we're going to be covering for your upcoming test for Chapter 7. So, first of all, this is our warm up question for today. As a class, I'd like you to take the next 5 minutes to see what kind of ideas you guys can come up with to figure out how to find the value of X. In other words, the distance from the boat to the hiker based on previous knowledge that you have done or used or any other ideas or concepts. So take the next 5 minutes or so just to kind of develop an idea in your head on how you would find X. All right, now that you've had some time to think about it, I'm going to kind of walk you through what some process is right now based on what you've learned and what you've done. So currently we know that we do not have a right triangle due to the fact that this top angle up here is not equal to 90 degrees and that top angle is equivalent to 77 degrees. So we have a 77, if I can write here, we got a 77 degree angle. So because that's 77, we know that that is not able to be able to use SOHCAHTOA because we don't have a right triangle. But what we can do is, since we do know SOHCAHTOA and we know the trigonometric ratios of sine, cosine, and tangent, we can drop in what's called an altitude. So the altitude of the cliff is going from the top of the cliff straight down to the side at a 90 degree angle. Because now we've broken it up into two triangles. Triangle with the 68 degrees of elevation with the 66 hypotenuse in the one triangle here. So we're going to label that triangle 1. And then we also created triangle 2 that has the hypotenuse of X with the altitude of, we're going to say in this case, Y. So using what we've done back in chapter 5 in the beginning of it and what you've done so far in geometry, we know that the smaller the angle, the smaller the side. Bigger the angle, bigger the side. And then we know that each degree measure has a set ratio that matches up to it. So for example, from 68 here, if I'm looking for the opposite and I have the hypotenuse, we're going to be doing sine of 68 is equal to y over 66. And then when we solve for y, you get y is equal to, by cross multiplying, you get 66 sine of 68, which then y is equal to 61.19. In fact, our rules for lengths, we're always going to round to the hundredths place. If you decide to change this to a decimal, please take 4 decimal places right here. This sine of 68, take 4 decimal places. Otherwise, at this point, I feel like you should be able to just type that whole thing in your calculator, get your answers. So that means 61.19 feet is representing the height from the cliff down to the water. Now that doesn't get us to X yet, but knowing the fact that 35 is across from the same Y value, if we can find Y like we did, we can now use that Y value to find X. So similar here now is that now that the Y is equal to 61.19, in this second triangle I can go sine of 35 is equal to the opposite, so y over x, which implies that sine of 35 is equal to 61.19 divided by x. So after we cross multiply, you get 61.19 is equal to x sine of 35. And then you divide, and that's where you get x is equal to 106.69 feet. So we want to think here and just compare a little bit about what seems realistic. Should x be bigger than y? Yes, because the 68-degree angle is bigger than 35. And should x be smaller than 135? And that answer is yes as well, because you have a 77-degree angle. So the larger the angle, the larger the side. Now, I'm sure in some way, shape, or form, when you guys are talking about this, you guys came up with this solution or this kind of idea. Well, this is kind of like an over-redundant amount of material that you have to do and process and analyze. So what happens was, if you notice sine of 68, sine of 35, this has created a formula known as the law of sines. So notice every formula here has a sine, so sine of 68. If I substitute this value into here, we're going to find the value. So what happens is the law of sines is then created. So a law of sines we can use when we're finding missing angles and sides of triangles that are not right triangles. This is, to me, my go-to choice. For me, obviously. I mean, I've been doing this for a while, and I want you guys to kind of have a go-to. So a law of sines we can be used when we're given an angle and a side that corresponds with each other. So in other words, if I give you an angle C here, let's say it's 60 degrees. And then I give you a side length of, let's say, 18 and another angle of 70 degrees. Well, then it's an angle-side angle relationship, so I'm able to use law of sines. So angle-side angle, if I'm giving you two sides, so if I give you B and I give you A, and I give you an angle that's not in between or not included, we can use law of sines. Also, if I give you two angles, and the side is over here. So instead of me giving you the 18, let's say if I give you, I don't know, let's say C is equal to, let's say just say 12 in this case. Angle-angle side relationship, we can still do that. So the key formula is right here, is that we take the sine of an angle, any angle that we have. So in this case it'd be 70 over the side that is across from it. So since this angle builds this side length, this angle builds this side length, and this angle here builds this side length, the bigger angle C is, the bigger the side length C is. So there has to be a ratio between those two in order to say that this angle ratio compared to this angle ratio and this angle ratio are the same. So key thing is capital letters are standing for angles, lowercase letters are standing for side lengths. I'm not always going to use A, B, and C. We're kind of, beyond that part right now. We're past geometry. But the key formula you're going to want to have written down or somewhere in your paper and would be the fact that we have the law of sines formula as well as the three relationships on when is the best method to use law of sines. And we'll talk later what happens if we don't have the other two relationships. We don't have them. So the key thing is I want to know how you guys derive this. How did this formula of law of sines get derived? So what happened was, same picture, same example as we had before, just a little scaled differently here. So how the law of sines is derived is that since x is their altitude, it's creating two similar triangles. And the reason they're similar is because this side is proportional, small leg is proportional to small leg. And then the small piece here in this triangle is proportional to that side. So since they have a common side in relationship, we can say, if we're going to find A, we can say that the sine of capital letter A, so in other words the angle A, is equal to x over C. Similar thing if we go to the second triangle. We can go, let's switch to a different color here. Sine of C is opposite over hypotenuse, so we can go sine of capital C is equal to x over little a. And if you notice, we've got common variables. So if I go ahead and solve this sine of a equals x c, I'm going to get x is equal to c sine of a. Same thing for this purple one. If I go ahead and solve for x in this one, I get x is equal to a sine of c. So if things are going to be equal, we have x and x, so we just set them equal to each other. So sine c, oops, let me erase that mistake there. sine, or C sine of A then has to be equal to A sine of C. And using the property of division and equality, if we divide by A on this side and then divide by C on this side, we end up getting the sine of A over A is equal to the sine of C over C. So just dividing here to go to the other side, you just divide here to get the other side, and there's your law of sines. So law of sines got created by SOHCAHTOA. So that relationship of sine, cosine, tangent is just that now we have a little bit more efficient way. Instead of dropping the altitude, finding the right triangles, and going through this 4 or 5 step process, we can now go into law of sines. So you will need to know how this is derived, so how this is created. So let's go ahead and try an example. Let's just try a setup here. So here's your example. How far apart is a plane from the 2 satellite dishes? So I want to know how far it is from here. We'll call that x. And how far that is away from here, which is y. So I always tell everyone with these law of sines is find everything you know. So right now we have an angle, we have a side length, we have an angle. So because we have 2 angles, we do have the third angle. And that third angle is equal to 130 degrees. Keeping in mind that 35, 130, and 15 has to equal 180 degrees in order for there to be a triangle. So now let's just use our formula. Our sine of A over A is equal to sine of B over B, which is equal to sine of C over C. So let's plug them in the way we want. Really any order that you want to find out. So we're going to go sine of 35 over x is equal to sine of 15 over y, which is equal to sine of 130 degrees over 20. So now you have what's called an extended ratio, an extended proportion. So to solve, to me, this is the reason why I do this. It's just a matter of picking 2 out of the 3. I can't compare 1 and 2 because we have 2 unknowns. But I can compare 2 and 3 to help me find the y variable. So to solve for y, we're just going to cross multiply these 2 values. And so you're going to get y is equal to 20 sine of 15, all of that divided by sine of 130. So if you want to punch this whole thing in your calculator, you got to make sure you put these in parentheses and make sure you put times up top here and then divide. So you want to make sure it's doing this calculation, then dividing by sine of 130. And when you do that, sorry here, I gotta look for a second. You get y is equal to 6.76 miles. So that distance for y is going to be 6.76. We kind of realize it needs to be smaller than 20. And now we just kind of do the same scenario. So we're just going to go ahead and find x. So let's go with, I don't know, blue here. We're going to compare 1 and 2 then. Or not 1 and 2. We're going to compare, 1 and 3. So you're now going to do sine of 35 over x is equal to sine 130 over 20. And as much as possible, try and go back to this original given segment that we have. So when you cross multiply, you get x is equal to 20 sine of 35, all divided by sine of 130. And just like I said before, when you punch this in your calculator, make sure you keep those in parentheses just to kind of keep those notation. I wanted you guys to do everything as exact as possible. So when you do that, you get x is equal to 14.98 miles, which does make sense since 15 is the smallest angle, should be the smallest distance. 35 is the second smallest one, and therefore your answer. If we were to put this back into the formula and cross multiply, we should have all those being equal. I'm going to cut off for this video.